Hello, everyone. My name is Rrezarta Krasniqi, and I'm a PhD candidate at University of North Texas. This paper is about generalizability of NLP-based models for modern software development cross-domain environments. So natural language processing has shown to be very effective for solving problems related to information retrieval, sentiment analysis, information extraction, then building chatbots via question answering, and also its ability to translate multiple language via machine translation. Yet, a very open problem nowadays with NLP remains in their generalizability for modern software development tasks that typically happen or operate in a dynamic environment. So what I mean by dynamic environment is that they heavily rely on third-party building blocks, such as Amazon AWS platforms or SaaS platforms. And then they also build up an interaction with external systems, such as ERP services or multiple IoT sensors. So what is even more challenging is that changes generally for these type of system happen in across platforms. They affect system business, operation processes, general system changes, program evolution dynamics, and even external changes such as cloud migration or rapid technology changes. So obviously, dealing with dynamic environments is extremely challenging when viewed from the NLP perspective, since such environments rarely contain a labeled target domain data. So in this paper, we position around one question. Can we generalize existing NLP pre-trained models for dynamic environments when labeled target data is limited or even unavailable? So here, this is just a simple example. A common way to approach this problem, which is, you probably even know, the transfer learning approach. So transfer learning in a machine learning method is where we reuse a pre-trained model, such as BERT model in this case, as a starting point for a model on a new task. So to put it simply, a model trained on one task is repurposed as a second related task on a second related task. And so by applying transfer learning to a new task, one can actually achieve significant higher performance than training with only a small amount of data. And so that's what we can see the relation. And now as we get some, with this, we can get some measurable evidence. So I actually was able to run some results using RNN, BERT model, and using fine-tuned data and for source data and the target data. So what we can see here is that fine-tuning BERT model using target data, see the orange, and the fine-tuning BERT model using the source data, the green bar, they yield some enhancement over training from scratch, the blue bar, but it does not scale across domains when labeled data from the target domain is not available. So then the question comes that unsupervised domain adaptation problem, in other ways, is still far from being solved, even when using fine-tuned pre-trained models that use only source data. So then now comes the question, what else can be done in this direction? So we ought to explore other more robust NLP alternatives. And those that we have thought about is using the embedding structural information, augmenting dependency relations with core reference chain, and also exploring inference and coherence in our neural machine translation. Looking specifically the embedding structural information, we actually look specifically the term incidental supervision signals. So in this context, supervision can be considered incidental if it makes use of signals that are correlated with a target task. And they can be used to provide supervision and facilitate learning. So they are often sufficient to infer supervision signals for a range of tasks and can be independent tasks. And they can substantially be less costly than producing explicit annotations. Another approach to go around is using attention-based probing. So I have actually tried to simulate here just through a short design, but basically the idea is to capture semantic correlation between the source and the target domain through the labeled source features and the unlabeled target features. And then we can somehow perform or adjust semantic information. By that, I mean semantic properties of the unseen classes that can be shared with those of the seen classes. And then considering that the distribution divergence of the two different domains can be disjoint, the original features are reconstructed by two different decoders based on the learning semantic representation. So the first decoder would design the properties of semantic space, that of the seen classes, and the second one is derived or inferred from the semantics of instances in the source domain. And then the third approach, so you probably heard that, I mean, using NLP, especially the traditional approaches, the inferences made by NLP models are generally correlational rather than causal. So using the MNT approaches, the focus transitions into causal effects. So for this aspect, we should focus on the domain invariant feature inference. What does that mean is that the feature inference is a domain invariant if the features follow the same distribution, regardless of whether the input data is from the source or target domain. So in other words, if we train a classifier that performs well on the source data using the domain invariant features, then the classifier may generalize well to the target domain here, since the features of the target data match those on which we train the classifier on the source data. Now, kind of getting onto the closing or summarizing, to have a future perspective or consideration, we should be more open-minded and have more even open questions worth exploring. One thing that came to my mind was that we have to think about now even further what kind of data should be used for the pre-training steps when dealing with dynamic environments. How should dynamic-based data be embedded in the pre-trained models? And how should we regularize an NLP model so that they could generalize better for unseen data distributions and unseen dynamic-based environments? And so with this, I conclude this talk, and I'm very happy to your questions.